Greetings from Rohini College of Engineering and Technology. This is Dr. T. Janishuga, Associate Professor, Department of Chemistry. Now I am going to present you a series of video lectures in the course CY 8151 Engineering Chemistry. So first let me start with the Unit 1 title, Water and its Treatment. I welcome you all to my series of video lectures. Let us go into our first topic. So before entering into our topic, we should know what are the students going to learn after completion of this topic or title. So the students will be able to understand the meaning of hardness of water, its types, and the method of estimation of hardness of water. And also they will be able to outline the various boiler feed water requirements. Then they will be able to discuss the boiler related problems, and also finally they will be able to summarize the various water treatment techniques. So before going into our main theory part, we should know about water and its uses and its sources also. So sources of water. So as we all know, rainwater is the primary source of water, and the other sources of water are oceans, seas, rivers, ponds, lakes and streams. So you can categorize the oceans into marine water or salt water, and others come under the rivers, ponds, lakes and streams come under freshwater sources. Now let us see the importance of water. We all know the importance of water in our day-to-day life. So it is used for domestic purposes and drinking purposes. It is used for recreational use and also for the production of power generation, agriculture use, and also in industries. All industries require water for their smooth running. We all know that the main purpose of water is the domestic usage or the drinking usage. So what is potable water? The water that is considered to be safe to drink is termed as drinking water, or otherwise it can be termed as potable water. You cannot designate all the water to be potable water because they will not be safe to drink. It may contain impurities. So in order to make sure whether this water is safe to drink, we have to carry over many tests. So now let us see some of the qualities of drinking water. So this water should be contaminant free, it should be mineral rich, it should have a slightly alkaline pH, it should have antioxidant properties, it should have a good taste, and it should have super hydration. Now let us go for the classification of water. Water can be classified into hard water and soft water. So now let us see what is meant by hard water and soft water. So hard water, it is defined as the water that does not produce lather with soap solution, but it produces a white precipitate. And the second one is soft water. It is defined as the water that readily lathers with soap solution. So in the given picture, you can see that the soft water in the conical flask is giving lather with soap solution, and the other sample, which is hard water, which has not given out lather with soap solution. So you can differentiate this, you can differentiate hard water and soft water. So why is this hard water hard? Maybe due to the presence of dissolved salts. So in the forthcoming slides, you can see what are the reasons for this hardness of. So now let us define what is hardness. So hardness, it is defined as the property of water that prevents the lathering of soap. It is due to the presence of dissolved salts of calcium and magnesium and other heavy metals. So now what is the reason for the hardness of water? You get the water from the maybe from the ponds, rivers, maybe the wells, but when you check it, you might find the water to be hard. So what is the reason for that is, this water which when it percolates through the surface of water or when it percolates underground, it crosses the deposits of limestone, chalk or gypsum, which are largely made up of calcium and magnesium carbonates, bicarbonates and sulfates. So, when all these salts dissolve with water, naturally the water becomes hard. Now, what are the different types of hardness? We have two types of hardness. One is the temporary hardness and other one is the permanent hardness. Now, let us define what is temporary hardness. Temporary hardness is due to the presence of bicarbonates of calcium and magnesium, that is calcium bicarbonate and magnesium bicarbonate, and it can be easily removed. So, it can be removed easily by boiling at least for 15 minutes and or by adding lime, that is calcium hydroxide. So, this temporary hardness is very temporary and so it can be easily removed by simple homemade techniques. But why the permanent hardness? It is defined as, or it is due to the presence of chlorides and sulfates of calcium and magnesium. As the name explains, it is permanent. It cannot be removed as easily as temporary hardness, and it has certain methods called as the external treatment methods for the removal of this permanent hardness removing salts. They are lime soda process, zeolite process and demineralization process. We will be dealing with all these types in the forthcoming videos. Now, how to express hardness? What are the units to express the hardness? So, generally this hardness is expressed in terms of calcium carbonate equivalence. So, why is this calcium carbonate having such a importance in the water analysis and water treatment? So, let us find out the reason. So, the first reason is this calcium carbonate salt is highly insoluble in water, so that it can be easily precipitated during water analysis. And second thing is that its molecular weight is a whole number, it is 100, and the equivalent weight is just the half of it, it is 50, and so it is very easy for calculations in water analysis even without a calculator or a calculating machine. Now let us go into the units of hardness. There are 4 important units of hardness. Let us define it now. First one is the parts per million. It can be abbreviated as ppm. It is defined as the number of parts of calcium carbonate equivalent hardness in 1 million parts of water, or instead of 1 million parts of water, you can write 10 power 6 parts of water. And the second unit is milligram per liter, and it is defined as the number of milligrams of calcium carbonate equivalent hardness in 1 liter of water. And the third unit is Clark's degree or degree Clark, which is defined as the number of parts of calcium carbonate equivalent hardness in 70,000 parts of water. And the last unit of hardness is French degree or degree French, and is defined as the number of parts of calcium carbonate equivalent hardness in 10 power 5 parts of water. So, in the previous slides we have seen what is hardness, what are its types, and what are the various units that are used to express the hardness. Now, let us see about the important method of estimation of hardness, or it is the most commonly method used for estimating hardness of water, that is estimation of hardness by EDTA method. So, though we have a number of methods like the alkali titration, soap titration method, this method is the simple method and it is easily handled by in the lab, ordinary labs itself we can handle it. So, this method is the best method for analysis of water samples for hardness. Now, let us go to see what is EDTA. EDTA is nothing but ethylene diamine tetraacetic acid, an ethylene molecule which has 2 substituted amine groups. These 2 amine groups are substituted by 4 acetic acid groups. But to the surprise, this EDTA, though we say it as an EDTA method, this EDTA is highly insoluble in water, so you cannot use it for water analysis. So what we do is, we do add the disodium salt of EDTA, and its structure is as such. Two hydrogen atoms from the acetic acid groups are replaced by sodium atoms, so you get disodium salt of EDTA. Now next step is we have to go to the preparation of solutions. Before that, let us look into the principle. As we all know, this water contains calcium and magnesium salts in the dissolved state. So we have to now estimate by a volumetric method. So first we have to convert this water into alkaline medium. For that we have to add a ammoniacal alkaline buffer, or you have to add ammoniacal buffer, which raises the pH to 8 to 10. So after adding the ammoniacal buffer, you have to add 1 drop of EBT indicator, whose original color is blue color. So when you add this EBT indicator to the water containing hardness producing ions, now it forms an unstable complex. This hardness producing ions forms an unstable complex with the EBT, which is a wine red color. So you get a wine red color. Now this wine red color solution is now titrated against EDTA at the same pH. Now this EBT is being kicked out and it is replaced by EDTA. Now the calcium magnesium complex with EDTA is a stable complex, but it is colorless. Now the kicked out EBT is giving its original color, that is the steel blue color, which is seen to our eyes. So you see the end point to be a change of color from wine red to steel blue. So this is the principle. Now let us go to the preparation of solutions. So the preparation of solution is very easy. So to prepare EDTA solution, you have to take 4 gram of EDTA and dissolve in 1 liter of distilled water. And to prepare standard hard water, we have to weigh accurately 1 gram of calcium carbonate and dissolve it in minimum quantity of dilute HCl, and you have to make it up to 1 liter with distilled water. And EBT indicator, you have to dissolve 0.5 gram of EBT in 100 ml of alcohol. And ammoniac buffer, you get the buffer as such, or you can prepare it by mixing 67.5 gram of ammonium chloride with 570 ml of liquor ammonia, and you have to make it up to 1 liter with distilled water. So a very simple procedure for the preparation of solutions. Now let us go into the procedure. So we have 3 sets of titrations. The first titration is standardization of EDTA. So for this, what are the steps? We have to fill the burette with EDTA, and we have to pipette out 50 ml of the standard hard water that we have prepared into a conical flask. Then we have to add 10 ml of ammoniacal buffer in order to increase the pH. Then we have to add 1 drop of EBT indicator. Now the solution, the water sample turns into wine red color. You have to titrate it against EDTA taken in the burette. You get the change of color from wine red to steel blue, which shows the end point. And now we have to note the value in the burette to be titer value, that is equal to V1 ml. Next procedure is estimation of total hardness. For this, we have to take EDTA solution in the burette. We have to fill the burette with EDTA, and we have to pipette out 50 ml of sample hard water. The water which you have brought it for analysis, that you should take 50 ml in the conical flask. Again add ammonia buffer and convert it into alkaline pH. Then add EBT indicator. Again titrate it, you get a wine red color. You titrate it against EDTA taken in the burette. You get the change of color from wine red to steel blue. You note the end point. So you get the titer value that is to be taken as V2 ml. Now let us go to the third titration, it is estimation of permanent hardness. So for this, we have to take 100 ml of the sampled hard water. We have to boil it for 15 minutes. And when you boil this water for 15 minutes, as we all know, temporary hardness can be removed by boiling. So after boiling, you have to cool it and you have to filter it. The filtrate is the water which does not contain temporary hardness. So from that, you have to take 50 ml of boiled, cooled, filtered sample hard water into the conical flask. You know that burette has to be filled with EDTA. The same procedure, add ammoniacal buffer, add EBT indicator, you get a wine red color. Now you titrate it against EDTA taken in the burette. The end point will be from the change of wine from the wine red color to steel blue color, and you note the value to be, the titer value is V3 ml. Now let us go to the calculation part. So first one is the standardization of EDTA. So as we have prepared the standard solution, we all know that it is a standard value that says that 1 ml of standard hard water will be equivalent to 1 milligram of calcium carbonate equivalent hardness. So 50 ml of standard hard water will be equivalent to 50 milligrams of calcium carbonate equivalent hardness. Now you can say that this 50 ml of standard hard water has consumed V1 ml of EDTA. So you can write V1 ml of EDTA is equal to 50 milligrams of calcium carbonate equivalent hardness. So we are comparing the second and the third steps. We get V1 ml is equal of EDTA is equal to 50 milligrams of calcium carbonate equivalent hardness. Now from this we can say that 1 ml of EDTA is equal to 50 by V1 milligrams of calcium carbonate equivalent hardness. This is for the conversion into calcium carbonate equivalent hardness. So next calculation is estimation of total hardness of water sample. So from here we have got the value to be, titer value to be V2 ml. So this V2 ml of EDTA can be written as V2 into 1 ml of EDTA. So in the place where you get V2 1 ml of EDTA, you can write 50 by V1 milligrams of calcium carbonate equivalent hardness. So we get 50 ml of standard hard water will be consuming V2 into 50 by V1 milligrams of calcium carbonate hardness. Therefore 1 liter of water sample is equal to V2 into 50 by V1 into 1000 by 50, that is equal to, we get the value to be, total hardness is equal to 1000 into V2 by V1 ppm. So I've got, when you get this simple formula I can apply, that is the second iteration value divided by the first iteration value into 1000, you get the total hardness. Now the next calculation is estimation of permanent hardness of water sample. So here we know the third titer value is V3 ml of EDTA. So V3 ml of EDTA can be written as V3 into 1 ml of EDTA. So in the place of 1 ml of EDTA, you can substitute 50 by V1. The same calculation, instead of V2 you get V3. So again we get permanent hardness is equal to 1000 into V3 by V1 ppm, or calcium carbonate equivalent hardness. Next is to calculate temporary hardness. We know the formula of total hardness is equal to temporary hardness plus permanent hardness. So now temporary hardness is equal to total hardness minus permanent hardness. Therefore we know the total hardness is 1000 into V2 by V1 and the permanent hardness is 1000 into V3 by V1. So on simplification you get V2 minus V3 by V1 into 1000 milligrams of calcium carbonate equivalent hardness, or you can say temporary hardness is equal to V2 minus V3 by V1 into 1000 ppm. So thus we are calculating the first one, the total hardness, then the permanent hardness, then the temporary hardness. So from this topics we have learnt what you can answer these questions which are most commonly asked for the university exam. Define hardness, and you will be asked about the different types of hardness and how are they caused and how can they be removed. And next important 2 mark question is, why is calcium carbonate chosen as a standard in water analysis? And next question will be, we will be asked to define any one of the unit of hardness, or we will be asked to define all the 4 units of hardness, and we will be asked to give the relation between the various units of hardness. And finally, as a part B question, the most important question is, explain the estimation of hardness by EDTA method. So with this I conclude my first lecture in water and its treatment. I hope you would have enjoyed it. Thank you.